Welcome everybody to a podcast of Klüber Lubrication. This is the second part of our episode about the lubrication of e-bikes. My name is Julius Fuchs and with me today is Matthias Kaufmann, a power transmission specialist working for the Freudenberg Group. The last time we learned how adhesion and wear protection of a lubricating grease can improve the service life of an e-bike mid-motor. Now, let's talk about efficiency. Matthias, I would assume that the load conditions determines the grease selection as well?
I would think so too. And talking about the lubricant, the grease viscosity is a decisive parameter that we should discuss today. The grease viscosity represents its inner friction, and it's not just influenced by its base oil. In addition, the thickener type and amount play an important role, as well as the operating conditions, such as temperature and shear rate. What do you think, Julius? How can we use the right viscosity to influence the grease and gearbox performance?
Matthias, I think we can learn here from experiences we have from our warm gear test rig. Even if we have more spool gears in e-bikes, an effect can be clearly identified. Therefore, a simple rule: at low loads, low viscous greases reduce loss in temperatures. Under high loads, high viscous greases increase efficiency and keep temperatures low.
Oh, great idea. That's really a good guideline at this point. And from my experience with e-bike manufacturers, I would suggest focusing on the most critical component in a multi-stage gearbox first. For example, if there are stages made of plastic and steel contacts, their selection should be oriented on the gears that fail first. If there are different gear materials involved, like in my example, with their specific requirements, often a trade-off has to be made because just one grease will be used for all stages.
Oh, great that you mentioned it. So we have to talk about compatibility of plastic gears. If the grease is incompatible, I don't want to see how rapidly the plastic gear will age, become brittle and reduce the efficiency or even break.
Fully agree. That's a disaster. So listeners, we can tell you a second rule of thumb. Have a look on the base oil polarity of the lubricant and of the polarity of the plastic material used for the gears. Never combine same polarities such as polar base oils and polar plastic materials. Always use opposite polarities. It means combine a non-polar base oil with a polar plastic material. That will help you with the lifetime. And this is just a rule of thumb. Of course, you should check it in detail, and additives have an important role as well.
Great discussion, Matthias. Here we already see it's really a trade-off, and we have to find a balance. If we only look on wear protection and adhesion, and the adhesive strength is too high, the drive unit will sacrifice efficiency and temperature will increase. If it is too low, there won't be enough grease available for a long service life.
You're absolutely right, Julius. And that's why you need Klüber Lubrication as your partner to select the perfect grease.
So Matthias, to summarize the findings from our discussion about efficiency and range extension, while we last time suggested to have a look on the consistency of a grease and saw how a certain thickener and NLGI grade improves adhesion and wear protection, we have to underline today that the right grease viscosity determines the efficiency and the temperature. At the same time, the compatibility with given materials needs to be checked.
Great summary, yes. And in our third and final part, we will give you more insights on noise emissions within e-bike mid-motors and how lubricants can influence the noise emissions. We are very happy to invite you to our final and third part.